Welcome back to Think Thrice Problem Solving. Today we're going to be solving a really fun power series problem that involves the famous Fibonacci sequence. So we have a power series, so that's a series of this form where we have a constant, a coefficient, times x to the n. We're taking the limit as n equals 0 to infinity. And it's going to turn out that this is equal to a very nice expression. So the coefficients in this are the Fibonacci sequence. So we have f sub 0 and f sub 1 are defined as just 1, and then subsequent terms in the sequence are going to be defined as the sum of the previous two terms. So if you'd like to see if you can simplify this, go ahead and take a minute and see if you can do it. Otherwise, we're going to jump straight into a solution. So what we're going to do is we're going to look at this power series, and I'm going to write it out now. So this power series is going to be the sum of a sub n x to the n from n equals 0 to infinity. It's going to be equal to, and then what I'm going to do is I'm going to write it out as the first two terms in the sequence. So we're going to have f sub 0, which is 1 times x to the 0, so we'll just have 1. And then same, f sub 1 times x to the 1 is going to be 1, or times x. And then I'm going to be adding this next term, which is just going to be the sum from n equals 2 to infinity of f sub n x to the n. Okay. So let's go ahead and look at this. So what are those f sub n's going to look like? So I just said above in the green that those are going to look like the sum from n equals 2 to infinity of f sub n, which is a sub n minus 1, f sub n minus 1, plus f sub n minus 2 times x to the n. So what we're going to do is we're going to look at this expression here and break it up into a few different pieces. So first we're going to look at the f sub n terms. So I'm going to rewrite this again. So I'm going to have 1 plus x, and then this is just f of x. So I'm going to pull out f of x is 1 plus x plus, now I'm going to break out the left, so sum from n equals 2 to infinity of f sub n minus 1 times x to the n. And then we'll have plus the sum from n equals 2 to infinity of f sub n minus 2 x sub n. And what I'm going to do here is I'm going to change our expression a little bit, and it'd be really nice if our expression had the same values in our exponents as it does in the terms of our Fibonacci sequence. So we're going to adjust those two guys. So we're going to change this to 1 plus x plus. And then this first guy, if I multiply this by x on the outside and I divide by x on the inside, then this becomes f sub n minus 1 times x to the n minus 1. And we're going to do the same thing here, but since I want this n to be an n minus 2, I'm going to multiply this by x squared to get the sum from n equals 2 to infinity of f sub n minus 2 times x to the n minus 2. And now we're going to look at these and do a little bit of a change of coordinates. So we're going to have 1 plus x plus, and then on the left side, I have x, and then I have this series. So we're going to write this as x, and then if I actually want to start at f sub n x to the n, I could see that my series here is going to be starting at n equals 1. So starting at n equals 2 and taking 2 minus 1 is the same as starting at 1 and just taking n. So we're going to go n equals 1 to infinity of f sub n x to the n. So I'm just changing my indices, but we can see that starting at 2 and starting here is the same as starting at 1 and starting here. And I'm going to do the same thing here, x squared, sum from n equals 2 to infinity. We're not going to start at 2. So we're going to start where? So if I want to go, instead of going from n minus 2 on the inside, if we want it to be n, then I just need to subtract 2 from my indices. So we're going to start at 0, and this will just be f sub n x to the n. All right, so we almost have something really, really nice. So I notice that this guy is now just f of x, which is what I just started with. And this guy, the red guy, is almost that. So I'm going to rewrite this red guy one more time. So the red guy is going to become x, and then I want to start at 0. So if I want to start at 0, my 0th term would be f sub 0, which is 1 times x to the 0, which is 0, so it'd just be 1. So if I wanted to add that in there, I could subtract it on the outside and then add it on the inside. So all I'm doing is adding that term on the inside. So now this guy is going to have one more plus, and then if I want to get rid of that, I have to subtract it on the outside. So I'm basically adding 0, but I'm making it so it looks nice in series notation. And then now this guy is f of x. So if I pull this expression down, now I have something that looks pretty darn nice. I have f of x is equal to 1 plus x plus, and then I have x times -1 plus f of x, and then I have plus x squared times f of x. All right, so this is now something that I can work with. So let's isolate our f of x terms. So if I do that and I put f of x on this side, I'm going to have f of x times 1 coming from this guy. And then we're going to have this x times f of x here. So I'm going to have minus x because I'm subtracting it from the right side and the left side. And then we're going to have this x squared term here, and I'm going to have to subtract that from the left side and the right side. So I'm going to have 1 minus x squared. And I'm going to have that equal to 1 plus x, so that's just these guys coming down. And then I'm going to have minus x coming from out here. And those are all going to cancel. And what I'm going to be left with is a very beautiful little expression. So f of x, oops, that's not a vector. So f of x is going to end up being 1 divided by 1 minus x squared. So it turns out that this power series that's described with coefficients from the Fibonacci sequence is really just going to be able to be calculated as 1 over 1 minus x squared, regardless of what your x term is. So this entire infinite series expression right here simplifies to 1 over 1 minus x squared, which is pretty darn cool. And if you'd like in a future video, if I get some positive comments, I might go into how we can use this then to calculate what the Fibonacci sequence is, actually the limit of the Fibonacci sequences. Sorry. All right, so please, if you enjoyed this video, like and subscribe, and hopefully I'll see you later. Thanks.